official shot. Good morning, ladies and gentlemen around the world. I'm proud to see, how many participants we have and how international they are. It's Africa, Europe, maybe not the US, they are still sleeping. Asia is here, so welcome. My name is Dominic. I'm the Managing Director of the Dryden Aqua Distribution. This is the Swiss operation. And pass it to you, Philip.
Yes, good morning. My name is Philip. I am the Managing Director for our operation in Scotland. I'm also responsible for our markets in America, Asia, and Australia.
Yeah, and I'm responsible for Europe and Africa as a market.
Exactly.
So we are not competitors. We are partners, we are friends.
Yep.
It's the Dryden Group, and we supply from Switzerland, mainly Europe, and from Scotland, the rest of the world.
Yes.
And in our middle, we have a new member.
Hello, everybody. So here I'm new since 1 year working for my friends in Dryden Aqua, and I'm here responsible for the water treatment applications and business. And I'm looking forward to our discussion today and presentation of AFM.
Yeah,
great.
So he is, Jochen is our director, and if you want, the boss of the water treatment division, where I'm managing from the process point of view, the pool one, because I'm coming from the pool. Okay, enough introduction. What are we going to talk about? Roger, you can start the presentation maybe. So I hope the ladies are not too disappointed that we disappear now in the corner and go to there.
We already have 92 participants.
Yeah. However,
just to make you not too much nervous.
No. My wife is also on the call. That makes me very nervous.
Okay, so that's the only one.
So today we give you an overview, about Dryden, who we are, and mainly about AFM, what are the benefits and where to use it. And we will have the next 4 weeks, 3 more seminars where we go more in detail in specific applications. Next one. Oh, sorry, I have to lead. Yeah. So Jochen, you want to lead us quickly through the agenda?
Okay, agenda. I don't want to go to any of these lines individually, but of course we have now the introduction of Dryden. Then we go through our filter media, AFM, just explain you how it works, how it is produced. And of course, at the end, you are welcome to bring up your questions, please.
And we do this.
Important. Yes, exactly.
We do this now.
Yes. So please click on that Q&A button you can see on the bottom of your screen. Here you can put in your questions anytime during the webinar. At the end of the webinar, we will answer your questions.
Yes, exactly.
If there will be no questions answered, because there may be too many, we will answer them all individual as well, of course.
Let's see, or we go on until 12. Okay. What is the red button here?
Okay, red button, of course, it mentions here already recording. We're recording this webinar for you and for everybody else who wants to watch the video of this webinar later on our YouTube channel.
Exactly. So we will be on our YouTube channel. We will do a second channel, right, Florent? Yes. Yeah. So we will inform you how that will work, but you will find it and you can rewatch us again if you didn't have the time or you want to see us again. I don't believe so, but however, let's start with telling who we are.
Yep.
Philip, you want to take the lead here?
Okay. So a few words about Dryden Aqua. This the gentleman on the upper right is Dr. Howard Dryden. He is the founder of Dryden Aqua. Howard is a marine biologist with a PhD in sand and zeolite filtration. And Howard is certainly a leading expert in water treatment. Howard has this unique knowledge combination of biology, chemistry, and process engineering. That makes it unique.
We call him the genius boy. Again, he is a marine biologist, but I've never met somebody who is that strong in chemistry. I mean, I've not met, maybe there are better ones, but unbelievable.
Yeah. So he developed AFM originally to eliminate chloramine and THM production to improve the living condition of sea mammals that live in chlorinated systems. That was the starting point like 30 years ago. And AFM was then, he continued to develop AFM about 15 years ago, started to bring it into some other industries.
Yeah, but I think that was more an accident.
Yeah.
I mean, he's our genius boy, or genius man. I have the highest respect. He is a fantastic scientist. He's not the best manager. I've ever met, right?
Yes.
He's not really the best manager. So maybe, yeah, before we come to this, a short story to me, because I met Howard in 2006. I went to Scotland. I heard about this AFM. I met him. I was 20 years already in the pool industry, and I thought I know everything about pool water treatment. And I found out in one day I know nothing. I learned in one day more than I learned in 20 years. And I got a virus, ladies and gentlemen, a very dangerous virus, the Dryden virus. And this virus we want to vaccinate into you because it makes your immune system on water treatment so much better. So I became his biggest fan, very good friend, good customer. I brought him to the pool industry, not just in Switzerland, also in other countries in Europe. And then 6 years later, he asked me if I want to move into Dryden, and we're talking about this in a minute. Mm-hmm. Today, we are in 3 different sectors.
Yes.
One of them is pools, where I'm coming from. You know, this is still our dominant factor or sector, you know, where we do 50% of our sales. And why is this? Because I'm coming from the pool industry and I had all my network, and we do really perfect pool water treatment, as you can see here with these 2 beautiful kids. Her mom is on the call. This is my wife. About 10% we do, talking about AFM in aquarium and aquaculture, and about 40% in water treatment, only 40. And this is why he is here. And this is why you are here, because we want to move this to 50, but not by decreasing the pool business, obviously. Huh?
No. And it's also the strongest growth segment by far.
Yes,
by far.
Yeah.
Huh?
And we are just jumping in. And here you see a little bit our roadmap, our agenda 2030.
Yeah.
You want to leave this?
Yeah, sure. So it kind of shows you where we are coming from. It really started out in about 2013 when we built our first factory in Scotland.
As 2012, it was a very small factory, very old-fashioned, doing a brilliant product, but you know, we had to buy a lot of resources and only made the activation. And you know, the turnover was roughly £1 million, which is at that time was roughly 1.2, 1.5 million euro. And we invested in a very latest fashion, state-of-the-art factory where we did all the process, and we invested 9 million, you know, from 1.5 sales. We invested 9 million, so it was
quite crazy.
Yeah,
crazy.
Brave. I would call it brave.
Yeah.
On top, I brought in Philip, because Philip, we are friends for more than 30 years. We met in the army. We were together in the officer school. He also was not in pool business. And I told him, hey, I have here a new challenge. It's fantastic. You will have to work double as much as you did so far, and you can earn half of what you had. And he said,
I said yes, but I think I misunderstood. But anyway, I'm still here.
So we haven't done it for money. Also, I left, you know, my company. I still own the company as a managing director, which was 30 times bigger than Dryden, and we moved in this small one. And together with Howard and all our fantastic members in the team, we developed it. So we did the first factory in Scotland. We founded Dryden Aqua Distribution. Because we are in Switzerland based, who was responsible for sales and marketing and a little bit organization. We did a Dryden Aqua Italy, then we did a Dryden Aqua Asia, Dryden Aqua North
sales
America,
office,
2 sales offices. And, you know, from 1,000 tons, we moved up to 15,000 tons. And then we said, okay, we are running out of capacity. This is why we have to do a new factory. And we built this here in Switzerland, just beside my other company. And we opened it just a year ago. And this is where we are here. You know, this year we will overpass 20 million euro of sales. We are a small company, but just focused on filter media. And in our plan, in our agenda 2030, you know, until then, we want to grow by a factor of more than 5. And we are very much on that track, which would mean roughly 100,000 tons of filter media, which also would mean 2 more factories. And where are they, Philip?
Yeah, so there is a race between the US and Asia for factory number 3. I don't know exactly where this will be, but we will have to make a decision soon. We are now going to be at about 30,000 tons of AFM. that we will sell. We have a capacity of a little bit over 50,000 with the 2 factories. So we will make a decision here soon.
Yeah.
The biggest.
But first, we have to sell it.
Absolutely.
You know? Yeah.
Absolutely. And the biggest growth opportunity that we see, and this you see is our focus for the next years, is our growth in water treatment.
This is why this is green. It's here. It's not red because we are communist. Okay, that was just the first phase where we focused on pools. Now our focus goes very much on water treatment without ignoring the pools and the aquarium sector.
Exactly right. Where are we? So we have our 2 factories, one in Scotland, one in Switzerland. We
2013, 2020 opened.
We have a sales office in the US. It's not just a sales office. We also have 5 warehouse locations in the US. So we are ready to supply any projects and any customers in the US. We also have a logistics base in Germany for some of the European or Eastern European markets, mostly, also Russia. We have a sales office in Shanghai with a partner there that we work together. And so we have a really good setup worldwide to do business.
Yeah. For such a small company working in 3 different industries globally, really globally, not strong yet in South America, but that might change. But really, we do about 2 to 3% in Africa, about 3% in Australia, 20%, 15% in Asia, 50% in the US, and roughly 60% in Europe. Yeah, we do quite some noise. And we do this because we have really the world's most sophisticated glass media manufacturing facilities. The one in Scotland from 2013, where we just upgraded it, over the new year. We closed it for 5 months and invested another 5 million euro to bring it on the same level as this factory, this very beautiful factory that we have here in Switzerland. So the Swiss factory capacity, roughly 30,000 tons. That would need 50,000 tons of raw glass. And in Scotland, roughly 25,000 tons. And we estimate to come close to 30,000 tons produced and sold media this year.
Okay.
Do you want to lead us quickly through the process?
So how is AFM made? Let's quickly talk about this. So we start with 100% recycled glass that we buy from the surrounding areas. The glass comes in, it's completely decontaminated, cleaned, and washed. We use here in our Swiss factory, we use 100% solar power to do this. We have 850 kilowatt hours.
All our roofs, even the facades, you know, the green color on the facade, this is also solar panel. So we really try to do it, as green as possible.
Yep. So paper, metal, plastics are removed by putting the glass through a wash cycle, spiral washer. Decantation, of course, we filter our water, our wash water.
We use our technology. It's wastewater,
absolutely.
and it's quite a heavy wastewater, you know, with decanters and then AFM filters, of course. And really, we just need water to backwash our filters. And for this, we use rainwater because we have all our roofs are where we collect the rainwater, and we have 1,000 cubic meters of rainwater collection. So we close the roof, even the sludge, you know, by washing. I mean, imagine the water comes, the glass comes in with 50,000 grams of organics. And after the washing process, it's 5,000. So we reduce this from 50 to 5. It's a factor of 10. It's a huge amount. And this creates sludge. And this sludge goes to the biogas, again, to make it as sustainable as possible.
I mean, it's very important to show here that we are also already doing water reuse, which is becoming one of the big topics in the world, right? Water scarcity is increasing, and we can demonstrate, even in Switzerland, where we have a lot of rain, we try here at Dryden to 100% use our own rainwater.
Closed loop cycle, exactly right.
But we do it because it's also more economic, otherwise it would be expensive. And then this was the washing, and then we go to the real factory.
Then we go through a drying process, and also in this process, we completely sanitize the glass. We heat it up to what temperature?
70, 80 degrees.
80 degrees.
And we have to dry it because in the next slide, we go through a color sorting. So we shot out the white glass. We don't want to have white glass. This is a very cost intensive process. First, this cleaning is very intensive, very very costly. And then in these beautiful machines, and it is amazing machines, which cost really a fortune, we remove all the white glass and just keep the green and the brown.
Yep. So why do we
wait, I tell you, in 2 minutes, we'll talk about this. Okay. So now we have the green and brown glass only. It's washed, it's sanitized, it's clean. And now it goes through 3 cycles of crushing.
Soft crushers.
Soft crushers.
You have it not sharp. They are soft. Our sharps are our grains are soft, right? So that's why we call it soft
vertical shaft impact, right? Then goes through screening and sieving. So
and
we
have 2: the beast, the big one, and the beauty. So we have the beauty and the beast, and they are also. You will see this in the video. The beast is the biggest screen in the world in a non-mining application. The biggest in the world. It's a little bit like Tesla. Huh? So we don't call it a gigafactory, it's a mega factory.
So now we have the precise particle size and shapes that we want, and this now
we have
the
very best glass media that you can have before activation, but it's not AFM now. Now we go through the activation process, and this activation process we will not share completely with you. Everybody's interested. What exactly are you doing? We will not tell you. It's like Coca-Cola. They also keep their recipe. It's a 2-step chemical process. This is what we can share. And then a thermal process where, again, we heat up the AFM on a very high degree, give to the product much more surface. We increase dramatically the surface. And we also change the structure of the glass.
Yes, yes. And then from there, it goes into the bagging plant.
Fully automated.
Yeah.
And shrouding, fully automated.
Various steps of quality control. And from then we ship it out.
Yeah. It's usually when we put it on the truck, it's still warm.
Exactly.
Okay, we have a nice video to show you this. And 2 minutes, we leave you alone. Enjoy it. Well,
Okay.
to be honest, we are very proud on it, and this is why we love to show it. But yeah, what this product is good.
Of course,
that's
good.
It's the very best.
It's the best product, but because it's the best product, you also need to use it in the best application or in applications, and we have all the certifications required. So you can use it in food production, drinking water treatment, and we have all the other certification to allow you to be safe and secure using our AFM in all of your water treatment applications.
Mm-hmm.
Yeah, yep. Perfect.
Good.
By the way, guys, we have 140 participants.
141.
I'm very excited, and we are very good in timing as well.
Yeah.
So great. So in order to understand really the benefits that you have with AFM, you have to understand sand or the disadvantages of sand. And sand is a very good mechanical filter that we know for many, many years, but it also has disadvantages. And one of them, it's also bioactive. Bacteria easily can grow on this, and this leads to some problems. And let's talk about this biology of sand filters and the main problems. Shall I take this, Philip? Or
I think it's your favorite subject, so maybe you do it.
Yeah.
The heterotrophs and autotrophs, right?
Yeah, I learned a little bit.
Yeah.
That's not my knowledge, really. This is coming from Howard. You know, in water, you have different bacteria. You have heterotroph bacteria. Heterotroph bacteria are bacteria who are taking organics as their food source and produce inorganics. Autotrophs are just the opposite. They're using inorganics and produce organics. Heterotroph bacteria, for example, Pseudomonas, they can grow very quickly. You know, if the conditions are good, 30 degrees of water temperature, there is enough food, they double every 30 minutes. So it goes really exponential. So all this, what we heard now in the last few months, it's a really exponential growth if the conditions are good. And for example, these Pseudomonas, you know, which are the pioneers of building up the biofilms, you know, they're in the water and maybe there is oxidation. They can be easily oxidized with oxidants, with chlorine or another oxidants, and they want to survive. So they try to reach as quick as possible a surface that is in contact with the water, so a wet surface. And that will happen within a few seconds. And the moment where they attach to a surface of a wet surface, they secrete a mucus, a slime, to protect themselves against chlorine oxidation. They want to survive.
That's actually the biofilm. Yes, that's the biofilm you see and feel.
That's what you call a biofilm. This bacteria covered by this slime, that's a biofilm. And this biofilm becomes very resistant against chlorine. And, you know, even very high concentration, here we wrote 50 ppm, which is an excessive amount of chlorine, you know, because the chlorine it cannot penetrate the biofilm. It has to oxidize through the biofilm from outside to inside. And by this, it's losing concentration, you know, and out of these billions and trillions of bacteria, even if you have a very high chlorine concentration, you will always have few survivors. Usually the ones, you know, which are strongest bugs, you know, the one which are very effective in producing biofilm, and then they are alone. And they have all the food and the nice temperature available. Huh? That's a bit like Robinson. Yeah, maybe Robinson is not good. And then they grow. So again, very, very quickly. And what has this to do with the filter media? Yeah, the sand is the biggest surface in contact with the water that you have in such a system. You know, you have a little bit of piping, but you also have the filter media. And 1 cubic meter of sand has 3,000 square meters of surface. So it's huge. It's 95, 98, 99% maybe of the surface that you have in.
And very important, that's not only in filter media, that also it continues. So there is a large filter area coming if you have an RO system from the membrane systems. Yeah. So that's another growth area for biofilm. And most of you who join here, they know about the problems. We will actually come to that in the next session next week. But anyway, I'd like to continue now.
Yeah, but also, you know, when you mentioned this, you know, this is also what we talked about. You know, very often you say, well, I have to chlorinate the sand filter to keep him free of bacteria. That will not work. It will not work. You know, often you see over a certain period of time, you know, over years, that chlorinated system, especially if they are on the same level chlorinated, that you get an even bigger biofilm problem than you have a low or non-chlorinated system. Through this process of natural selections, you kill the weak box and you leave the room to the strong box.
That's very important. Yes.
So if you do chlorination, do me a favor, do shock chlorination. And then, bacteria do not like they like to have it always the same conditions, like we do.
Humans,
right?
Like the humans, yes, we try
they like their comfort zone, huh?
Yeah, comfort zone.
So what's the problem then, really? The problem with biofilm in sand?
You want to take that?
Yeah, should I?
Yeah.
Okay. So the problem that we get when biofilm grows in sand is that it leads to clumping of the sand grains. They start to stick together, and ultimately you have channels. You can press a few times. You have channels that are starting to form through the filter bed. So this leads to a very inconsistent and unreliable filtration. It can happen that unfiltered water actually gets through the filter. And this is obviously something that we need to avoid.
I mean, that's like highways. So water goes through these highways.
Absolutely.
Yes.
So you have turbidity that increases, that spikes up and goes down. It's very inconsistent.
Yeah. And also what you see here these channels, and from time to time when these channels are opening, you have a breakthrough of this biofilm. And this is when your product water gets very high turbidity. This is when you have this breakthrough of this. Yeah. Now you will maybe say, well, Dominic and Philip and Jochen, this is not happening. When I change my sand, it's working perfectly for 3 months. This is true. Problem starts after 3, 6, 12 months, depending on the temperature, depending on the load, depending on the backwash regime that you're having. But it's starting a little bit later. And why is this? This is because of these autotroph bacteria. Because when they move into the system, they produce the food source for the heterotrophs. And this is when this biofilm problem starts to become a lot more dramatic. And they are not doubling every 30 minutes, but every 10 to 12 days. And this is why this takes a lot longer to move them in. But if then they are in, it's
becomes very dynamic. Huh?
Very dynamic.
The big issue is you get more bacteria out at the end as you get in.
Yeah,
and that can be a big problem in other processes downstream.
Yeah, that really can happen. If you measure the bacteria level in your raw water and your product water, and they are in your product water higher than in your raw water, that's not really good. And then, of course, you can do with chlorine dioxide and chlorine and whatever to avoid all these problems: turbidity increase, biomass increase, suspended solids and biomass discharges into filtered water. No reliable filtration. Yeah. There is an easy way to avoid this. In order to solve the problem, the easy one is use a bioresistant filter media. And there is one I really can recommend you, and it's called AFM. Yeah. Maybe you're surprised.
Yeah. Okay.
Philip, please explain us why this is.
Okay, so how is AFM bioresistant? How does this work, right? We mentioned a couple of minutes ago, we use only green and brown glass. This is very important because green and brown glass contain metal oxides, chromium oxide, iron oxide. And on the surface of the grain, there's a catalytic reaction that now takes place, where these metal oxides react with oxygen in the water, and this forms small amounts of free radicals.
This is what you see here. These are the hydroxyl radicals. So you have H2O, the water. You need a certain amount of oxygen, not a lot. 2 ppm of dissolved oxygen is enough. But if you have this on this surface, and remember, in the activation process, we increase the surface by a huge factor together with the metal oxides. So you're creating these free radicals.
Yeah,
I show it again because I like this. Yeah. This is from Flo. He's also here. This is what you're turning. It's a small amount, it's a small amount, but it's really enough to protect these bacteria who want to reach the surface of AFM, to attach, to build up a biofilm, because they want to survive, to protect this. They cannot move in.
If I want to jump in quickly here, it's very important. This is the activation which we make through our production process. So that's not for clear, that's not for all the glasses. Just that people don't misunderstand. That's not a normal glass, that's our activated surface area.
Yeah, I mean, first thing, as a raw material, you have to have the metal oxides in. If glass manufacturers are using green and brown glass only, that already gives a benefit. But the other is because you increase the surface by such a huge factor, and this is a surface reaction. You know, if you increase the surface by a factor of 100, obviously you have 100 times more free radicals, which protect you against this biocanalization. Yeah, I think we are doing it pretty good as a team.
Yeah, that looks good. Yes, and actually, just going here to the topic of biogrowth on surface areas. Here, a picture of sand, clean, new, fresh sand on the left side, and after a couple of days, you see the growth of bacteria. That's normal for every surface area, as we explained before. So after 3 days, you have a colonization of bacteria. If you take then AFM, also fresh AFM on the left side, and then here in this example, after 5 years, there is no bacteria growth. So we proved that this hydroxy radical generation on the surface area really protects from biofouling. And most importantly, why do we want to have this? This is because we don't want to have these problems of biofouling, clumping in the system, and unreliable filtration. So we improve this dramatically by using AFM.
Yeah, and now you're engineers, can you measure the hydroxyl radicals? No, you can't. But we can do what one of our customers in New Zealand has done a couple of years ago, actually. You know, he let run one system, I think it was a drinking water system, you know, with one filter with AFM and exactly the same filter, one with sand. And he operated them for 6 or 9 months. And then after a decent backwash, he took out 5 grams of filter media, put it in sterilized water, and then put it on the Petri dish. And this is the difference in the germ counts, you know, 18 to 3.6, which is a factor of 1 million. Now, 1 million is a big number. I always say a factor of 1,000, and then you come and say, Dominic, you're wrong. It's not 1,000, it's 1 million. Okay, I'm happy to make these mistakes, to get these corrections. Okay, next topic, let's talk about the surfaces and the filtration properties. And first we want to start with this. You know, we have 2 types of AFMs. Until 2-3 years ago, we only had our AFM and nothing else. And since 2 years, we have now AFM NG, and NG stands for
next generation.
Next generation. So yeah, this is like with the iPhone, each version gets better, right? And this is why we call now our old AFM standard, which is fantastic, a brilliant filter media, and AFM NG, the next generation, which is even better. And the better is the enemy of the good. What do they have in common? They have in common both that they have the self-sterilizing surface. Both of them are bioresistant, and both of them have a completely increased surface. I pass this now to you because my colleagues always say you take all the lead.
You like to talk, everybody likes to talk here, so we try to balance that at least as best as possible. Coming back to our difference here to other medias, but which is same for the AFM standard and the AFM NG. So here we have the high surface area. What that means, this looks like a little bit like the Swiss Alps, but that's maybe also important because on all of these surfaces, we generate these free radicals. That's why we have this very beneficial performance of not only having a self-sterilizing, but also a superior mechanical filtration performance down to 1 micron. We'll show you in the next slide. But more important here is we let me
clarify this, you know, because that was maybe a little bit fast. So the increased surface has two consequences. Much better filtration performance and much more bioresistance.
Exactly, yes, thank you. Okay, coming to the mechanical properties, we are not doing absorption. We really only do adsorption on the surface, means in this case, all the particles are adsorbed on the surface area and easily backwashed, removed from the media during a backwash process.
What's the difference to absorption? What is an example for absorption?
Okay, let's take an absorption. I mean, most of you who are here, they know activated carbon. Activated carbon is a perfect example for absorption. So you have a lot of mesopores, long, deep channels where these bacteria or small particles, they go into, attach to it, The problem is they are not removed. So that means they work perfectly at the beginning of a filtration process, 1 week, 2 weeks, maybe 2, 3 months. But suddenly after a couple of months, they don't work. They start to have biological growth, and then they don't work anymore as they have promised by the suppliers.
No, I think
so
we don't want to blame it at all.
Saturated in a way.
It's saturated, yeah. It builds up biofilm, and
Mm-hmm.
then there is end of lifetime, you know. And I mean, honestly, I mean, with activated carbon, you can do few things that we cannot do. So we also work using our process activated carbon. It's not to blame carbon. It's just to say this is a fantastic filter media, but it's absorption, and that means you have to replace it. Or if you take zeolite, it's the same thing. You know, it's very huge in the surface, fantastic for absorption, but it has to be regenerated in a very
you can do this, but it's
a difficult process.
It's labor intensive, and you can only do it a few times.
So here we really
the same is with activated carbon. You also can reactivate it. We don't need this with AFM. You just make a decent backwash, and then you can keep the product for many, many years.
Yeah, we don't talk about chemical removal here. Really, we talk about mechanical filtration properties.
Mm-hmm. Okay. So that's what both products have in common, huh?
Yep.
These two things.
So, Philip, you want to take this?
So what's so one thing that's unique for AFM standard now, right? Yeah. That's unique to AFM standard is that AFM standard has the activation chemicals that we apply to it give AFM a negative surface charge. Huh?
A very high negative surface charge that you see here.
So this makes AFM standard very good at attracting positively charged particles. For example, and this is why this is the main application where we use AFM standard today. It's in the reduction in the filtration of heavy metals, iron, manganese, arsenic that are precipitated.
Yeah, exactly. So again, to clarify it, you know, AFM standard is a great product, fantastic product. We just have now a better one, the NG, for most of application. One of application where AFM standard is better is heavy metal removal. Yeah, and we talk about this in detail in the session number 3, where we talk about iron manganese removal, drinking water, beverage industry. So if you're in this field, please join us. AFM-NG, the better is the enemy of the good. You know, Howard has developed this to remove microplastic. I mean, AFM standard is not perfect in removing microplastic if you don't add coagulation, flocculation. So he wanted to develop something which is a non-polar, which has no charge, which is hydrophobic, and which can really remove microplastics. Howard today is not anymore that active. I mean, he's always available and helps us, but he passed his role as the chief technical officer to his son, Matthew. Brilliant guy, brilliant man. So we have all his support, but Howard's focus today is on GOES, on the GOES Foundation. You want to say a few words to the GOES Foundation?
Yeah, I mean, this is a foundation that he started to drive, initiatives to improve, the health and the quality of our oceans, basically. He's very much concerned about that. I think we all are concerned about pollution of our oceans. And so this is what Howard is doing now.
To keep it short, he says, well, the biggest problem is that we have in the ocean. If we lose the ocean, we lose the planet. You know, it's the base of our life. And one of the big problems are microplastic that we have in our drinking water, that we have in our wastewater, that we have in the oceans. Why? Because on the microplastics, you coagulate, you concentrate all the toxic chemicals, and then they come in high concentrations and move up the food chain. From the plankton to, and especially the plankton, fish, you know, we lost 40% of the plankton in the ocean. So the last 70 years, this is a problem. And this is why we really should avoid microplastic or filter them out. Now, how to filter microplastics? You do this because they're hydrophobic. They don't like water. You have to use a hydrophobic filter media, such as activated carbon or AFM-NG. And when we had it, you know, we also found out when we tested, this is great for microplastic, you know, it's amazingly great, but also for other organics or for organics, proteins, oils, lipids. And we found out it's even better than AFM. And yeah.
I mean, here very important is like in water treatment, let's say seawater desalination processes, there's a lot of oil hydrocarbons in some of the open intake seawaters. We can remove that oil with our filter media together with the perfect high filtration of particles, and we can really achieve super clean water after our filtration process.
Yeah. Roger, I cannot, I don't have any more control.
No,
Thanks,
okay.
I have. So it's very good for this. Let's explain maybe a little bit hydrophobic, hydrophilic. Philip, you want to take this?
Yeah, okay. So we were talking about AFM standard which is a hydrophilic media, which means it loves water. It allows hydrogen bonds to happen. And hydrophilic molecules like other hydrophilic molecules. It's like humans, you know, some like this and some like the other, right? On the other side, we have AFMNG, and it was mentioned AFMNG has a hydrophobic surface, which means it repels water, and hydrophobic substances like each other, right? So this is why AFMNG with its hydrophobic surface is very good at filtering out other hydrophobic substances, such like hydrocarbons or microplastics.
Yeah.
Yeah, and here on this small video, we can easily explain you. On top, you see AFM standard, hydrophilic. Below, you have AFMNG, hydrophobic. You see, this is a super hydrophobic. You will not get it that hydrophobic, but you clearly see the difference, you know, and that also is, you know, when we started, people said, well, Dominic and Philip, you're nice guys, but I think you're marketing guys. There is just marketing, you know, where is the activation? Can you prove it? And you can, but it's quite a difficult process with AFM standard. You have AFMNG, it's very simple, you know, very simple, you can show it. So all clear, AFM standard, AFMNG.
Maybe to mention that it's not floating, yes, even if it's hydrophobic, it's not floating. So we have really control over the production process, so that works perfectly as a filter media.
Yeah, we also write this in our manual. You know, you have to treat it a little bit like activated carbon. You should not. You should put it in water and leave it there for 24 hours before you make your first backwash, because the first few hours, few particles are floating.
Yes.
And it's also normal that there is a little bit of fines in that you will lose in the first 2-3 backwashes. That's kind of normal. They might be also, you know, also I mentioned before in the washing process that we reduced the organics from 50,000 that the raw glass has to 5,000. Then in the full process crushing, you know, where we always suck and blow the contaminants out of it and the activation, etc., we bring it down to 5 grams organic. So in 1 ton of AFM, 5 grams organic. Mainly paper, but it's nothing. And also this, you might have a little bit on the filter bed of the first,
second backwash.
Yeah, absolutely. But to summarize, you know, in this activation process, we decide, do we make AFM standard, high negative surface charge, or we do it AFMNG, hydrophobic. This for most of application, organic removal, this especially for heavy metals. Okay, you want to take this?
Yes, thank you. So besides having 2 different filter media AFMs, we also have different types and grades. Here first, grade 3, that's our support layer. Mainly we use that in the application to support all of our other grades coming on top. Important is here, this is also self-sterilizing. So we really want that our filters are purely using our AFM, because this provides you with the best filtration performance. There's no biological growth on the bottom or in all of the filter where you use the AFM.
So no gravel, etc. If you do it on your risk. Don't come to us and complain, well, I have now bacterial growth. You can do this if you use only AFM. Okay, but that's really to cover the laterals, to make a support layer, and then the grade 2 that you can use if you have a nozzle plate, you know, with a slot size of 0.5 or 0.2 millimeter, you can use the grade 2 only as support layer. The beauty of this grade 2 NG, it's filtering fantastically. Not as good as the grade 1, but fantastic. I mean, down to 5 micron. So as good as our old AFM standard, it's really amazing.
So you can use it as a support layer or as a filtration layer.
Both together.
You can't use it as it is a hybrid. It works in both directions.
Exactly.
It is working as a support layer, but it's on top of filter layer. And this is why we also changed a little bit the layering. I mean, about the layering we talk later on. Okay.
Okay, so then next layer, that's actually the main filtration grade. That's the grade 1.4 to 0.8 millimeters. This is really the one you can get as NG or as a standard. As we mentioned before, 2 different types you can use as the main filtration grade. Here we really go down, outperform superior performance of filtration of particles better than any other filter media, down to 1 micron.
Already with the grade 2, by the way.
Of course, yes. But even better, improved by grade 1.
Yeah, sure. Because you have more surface, the smaller the grain size, the more surface you have. And
exactly,
with the grade 0, this is very fine. You know, it's not powder, but it's really fine, 0.25 to 0.5. This goes then really to, we couldn't measure it, but I guess it's 0.5 micron, so it's very fine. But this one we cannot do in NG. It's technically not possible. So we use the grade 0 if we need very fine filtration, if we cannot use coagulation and flocculation, or if we have very low backwash velocity, you know, in existing installations. I know it's getting a little bit complicated. We can, but we will, next one, please.
Yeah. So actually, maybe important to mention at the end is, yes, we can even put another layer on top of it. Yes, if you have a high load of suspended solids, then we really recommend you add anthracite on top, 330 ppm or higher of turbidity of suspended solids, or turbidity more than 10 NTU. We really recommend to add some anthracite, not just because you have a better filtration. This is really to use to improve your run phase between the backwashes.
Yeah, the only thing, you know, this will not improve your filtration performance, not at all. It's just filtering the heavy particles, or for example, in your pre-treatment before RO, if you have an algae plume, you know, in this open intake, you know, instead of having these algae, which will make a layer and block the filter bed, you crush it.
Exactly. And then you, for example, then you're using grade 0 sometimes, because some of these algae are very small. Sorry.
Now we are overcomplicated. That's in the next session.
Next session.
But maybe, let's come quickly to the design parameters. You know, in filtration, the lower you filter, the better is your performance. That's a general rule. And you can go up to 30 meters per hour, but of course you compromise the filtration performance. You know, in pools, for example, this is the maximum speed that we are doing, sometimes also in aquarium. Water treatment is more between 5 to 15. We can go higher. The best what you can do, come with your project to us. I mean, I'm not talking about project, you know, with a 20-inch diameter filter. I'm talking maybe a little bit, you know, what you
like
see.
What you,
yeah, exactly. Come with this to us. Yeah. Tell us what's your application, what is your raw water, what is your target water, what is your process, and then we are really happy to come on to comment on it. You know, to help you in doing the process the best possible. I mean, we are not detailed engineer. We are more helping you in the process. I mean, you, ladies and gentlemen, I mean, you cover such a big band, you know, you have to know everything about water treatment. It's a big field. We can concentrate just on this, but in the filter media, we are the best.
We are the experts, yes. And backwash velocity also important. I mean, you can see there is also a range of 20 to 50. Of course, this is usually we want to have a high filtration speed.
Yeah, let me come in the next 2 days. Exactly. But that's more or less the range that we want to have the backwash velocity.
And all of this is important to mention. We have our instruction for use.
Yeah, that will come in a minute. Now you take more and more the lead here. Huh? You complained before, you take too much the lead. So you adapted to me already quite well. One word to backwash velocity. You know, I'm coming from the pool industry, and for me, ladies and gentlemen, you from the water treatment, you are for me the heroes, and you still are, of course. But because of backwashing process, I have seen many installations. You know, we're filtering at 5 meters, backwashing at 10 meters, and where I disagree. Maybe we have now 153 participants. Maybe I lose half of it, but I will.
Let's see.
I say it. This is wrong. This is wrong, and I will show you later on wrong. So about backwashing, we can talk a lot more, you know, because backwashing, this is your IFU. It's a very good document from Howard and you and Matthew. Very good document, easy to read, but again, come back to us, let us comment, you know, to start the cooperation, and then after 2-3 projects, you will be sure, and then you can do everything on your own, and we also will have some calculators. I will talk about backwashing a little bit more in the next slide. AFM, the filter media is a software, but you also need a hardware, and hardware is the filter. And as you all know, there are different hardwares. We have the horizontal filters with laterals or with nozzle plate. We have the vertical filters with laterals and with nozzle plate. Horizontal filters are not the best. Vertical filters are a better hardware than horizontal filters. Why? Because here you have equal flow, equal speed. In filtration, it will not change velocity, and also not in backwash. In the horizontal filters, you start slowly, then you get fast. And in the backwash, it's the opposite. You start fast, and then you get slow. They're perfect, these horizontal filters. I mean, for the same price, you get much more surface, and this is overcompensating the disadvantage. But just that we have mentioned it, you know, as a basic knowledge. Obviously, the very best is the vertical filter with nozzle plate, because with a nozzle plate, you're sure you have an equal flow. You have a very equal flow of water. Here in the laterals, you depend if you have a very good manufacturer. One of them is this guy here, the blue one, the Colplus, you know, where they have really, we have seen this in design classes where they have a very equal flow, but some of them are not good, you know, where you don't have an equal flow, where you just have all the water in the middle. Even worse, if you do it with, if you make an air wash, air scouring. Scouring?
Yep.
Scouring.
Yep.
You know, I was shocked to see in 2-3 installation where they had laterals, you know, it was even in horizontal filters where they did air scouring. I mean, air scouring is very important if you have sand. Why? Because you want to scrape off the biofilm from the sand grains. There you have to do it, and it works. Not 100%, maybe 90%, it works. And this is why you need air scouring, but you don't need this for AFM. If you do this air scouring, let's forget about AFM, let's talk about sand. If you have these filters and you make air scouring or these filters, you know, this air will not go over the filter, it will just stay in the middle. And there you explode the air up, and the only thing that you do, you mix up the filter bed, you mess up the filter bed. And if you don't have very, very high backwash velocity, you will not be able to reclassify the bed. So for today's session, if you take one thing with never do air scouring if you don't have a nozzle plate. Forbidden. It's not forbidden, but you damage your system. If you don't have a nozzle plate, don't do air scouring. That's number one. Number two, back to AFM. AFM, of course, works best, our software, in the best hardware in this filter, but it will also work brilliant in these filters, especially also in horizontal filters, especially in lateral configurations, because you don't need this air scouring. And the third point is the weaker the hardware, the bigger you will see the difference in the software.
Yeah, that's why AFM performs in all of these filters much better than in sand.
But especially here, you will see huge difference.
We see this also in the case studies later for existing horizontal filter
He wanted
changes.
to tell Dominic, you're over,
Gravity filters.
Gravity filters, yes, you see
that's
this,
your thing now.
Yeah, that's actually one filter I was just filling up together with the customer a couple of weeks ago. It's running now perfectly fine. It's green, so it's AFM inside. It works perfectly, much better than sand in this application. Just to mention, you know, not only do pressure filtration, so if you have any questions of using AFM in rapid gravity filtration in general, please come to us and we can help you to design the right filter bed.
Gravity is great, and it was his first project, and he was on the installation. He was blowing in this AFM.
Yes, exactly. It was a little bit green, but it was okay. Yes.
Yeah. So that means you go now for each installation and blow it
I will
in?
not probably go in for each, but of course, if you call me a customer, I would
the
like
answer
to
is no. We don't have the budget for do this.
Okay, then.
Unless you're in Switzerland, then it's not. But as we said, we can use it in vertical filter. That's an installation that we have in Bangladesh, one for groundwater and one for heavy polluted textile water, 300 cubic meters a day. This I pass again to you.
Yes, okay, that here you can see that's huge of horizontal filters. These filters are currently filled with sand. This is a desalination plant.
With laterals, backwash with air.
Backwash with air.
Completely wrong.
SDI, incoming SDI, I think it's around 5 to 5.5. The outgoing SDI in this situation, and this plant is only about 4, so that's
4.5.
4.5.
So,
okay,
incoming 5, out of the filter 4.5. And we will ship in 2 weeks the first filter,
exactly,
AFM for the first filter, and then for the next filter, and then we fill it up. And I'm very, very sure we will halve this. We will be
between 2, around 2, yes.
Yeah, around 2. Yeah, but we show you when we have
2 means an SDI of 2. Yes, if you talk
SDI
about
of
figures.
2.
Yes.
Yeah, sorry. Yeah. Okay. Shortly for the performance, Philip, you take this.
Yes. Okay. So you can believe us what we say. We are trustworthy, but maybe even better, believe the white papers, believe the tests. So these are the test results that have been conducted by IFTS, French Institute for Filtration. You see here the particle removal rate on this axis. On the horizontal, you see the sizes of particles. What you see here is that AFM NG grade 1, that's this green line here, is removing, sorry, it's this one here.
So the lighter green, yeah.
So we have, okay. So we have a removal rate of roughly 95% of 1 micron particles. Then for AFM standard grade 1, we have a removal rate of 95% of 4 micron particles. And if you compare this now with fresh new sand, best performing sand, no biofouling, you see that 95% removal performance is at 20 microns. And this may not look like much. 20 microns is small,
huge.
4 microns is a bit smaller. Yeah. It's a huge difference. It's a planet in between. It's a planet.
Oh, it's actually a galaxy.
It's a galaxy.
Okay.
Exactly.
However, one thing I want to mention, this was measured at 20 meters per hour filtration velocity. So not best condition for water treatment, but these tests cost a huge amount of money. We can all do these tests, of course, in our lab as good, even better. But we want to go to IFTS to test this independently. We also tested a lot of glass medias, and they were terrible. I mean, sand was after AFM the best, and you see between sand and AFM standard, it's a world in between, and to AFM NG, it's a planet in between. So we also have this in a report.
Exactly, as I wanted to say. Yes.
Mm-hmm.
And
and you can download it.
You can download it from our website. Yes.
Good. So where does it fit in?
Exactly. So where does this fine particle removal fit into a scale for process of separations in particulate filtration, micro and ultrafiltration? Sand is in typical particulate filtration. So here, that's the typical, everybody knows we use sand for pre-filtration or for filtration in drinking water before RO membranes. But now the game changer is now with AFM, we can go down to microfiltration. Even further down, if you use some coagulants and flocculation, we can go to 0.1 micron. So we are actually touching now the ultrafiltration membrane market. So here we really close the gap between filtration, media filtration, and membrane filtration. So I think that's important to know and to understand that this is different to before. So we really offer here a new solution on the market. Besides standard filtration, media filtration, which we do superior to sand, we also go down into micro and ultrafiltration.
Perfect. I have to lead back. Okay, let's talk quickly about backwash. My comment before, we didn't lose everybody. We still have 150 people. Yeah. This is this lab, IFTS, Institut Filtration Technique Separative. And here you see how they test AFM, and now they do a backwash. And here, now you see in this column that we usually do not have, you see the bad expansion. And bad expansion of minimum 15%, better 25% is really important, because you have to bring, these adsorbed particles on the surface, you have to bring on the surface of the filter media and then to wash them out. And to wash them, and for this you need a certain velocity of the water. It depends on the water temperature, it depends on the size grade, and it depends if you have sand or glass. Now glass is 20% lighter than sand, and this is why you need 20% less of velocity. And we have tested here sand, and we have tested here, of course, AFM. And, you know, sand usually needs the grade 1s, 30 to 50 meters per hour backwash velocity. Same size grade of sand needs 50 to 60. And if you backwash it really at 50, we only need 3 to 5 minutes. We can go down to 20, you know, for existing installations like this project that we have seen before as Contreras. We only can backwash at 20 meters, then we just take more of grade 0 to compensate this, because there you have higher bed expansion. But again, don't bother about this. We all will do this together with you. But these columns you need to understand that you need bed expansion. And if you backwash your sand filters with 50 meters per hour, I promise you they will not backwash. Open the filters, look in the side glass. Usually they are non-side glass, and you will see 0 bed expansion. And what a lot of people do then, they compensate it by backwashing it for 45 minutes, even 1 hour. This is stupid.
Nonsense.
This is nonsense. And this is something that we will not do. You know, if we are below 20 meters, we don't have a solution. If you say I cannot go higher than 10 or 15, we don't have a solution for you.
I mean, you need to overcome the specific gravity. Yes, the natural gravity needs to overcome. That's why you need speed to flush out all of your particles.
Yeah, that's especially if you have heavy particles like heavy metals, then we need 40, 50 meters to wash them out. But also just for the bed expansion, we need a certain velocity. Yeah. So we talk a little bit more in detail in the coming sessions about this. We still have not lost we still gain people. This is great. Yeah. But this is how it looks like. This is a backwash process, and this is not so known in water treatment. I was very surprised by this. It's not to criticize you. So we come to the end and just give you a few case studies that you see, you know, where you use AFM. You want to take the first one?
Yes, I will take the first one here. That's a refinery in Greece. Here we work together with our partner who have installed this great installation, SciChem. Thank you very much. I think a couple of our colleagues from SciChem are here. So congratulations to this very...
Calimera.
Yes. Yeah. This is a really good running plant. So we use this in this case for RO pretreatment. So here in this case, we have cooling water, blowdown water, which is treated in one of these plants. And in the other plants with the vertical filters, we are treating the water, seawater, to add more on the cooling tower treatment process. So this is a combined plant treating kind of, let's say, wastewater from the cooling tower and fresh seawater from intake. So here we achieve an SDI of 3 from starting of larger than 5, and we achieve a very good turbidity of less than 0.5 from starting a turbidity with 10. This is actually quite large installation, 1,100 cubic meters per hour, so that's not really small. That's a very important process for this refinery, and all of the targets has been achieved.
Yeah. So my friends from SciChem, Nick, and your colleagues, you know, I'm not so happy with this less than 3, but we haven't got really deeper data from you, and you're great guys. You make fantastic installation, but provide us a little bit with more data. Here with the turbidity reduction, I'm very happy. Okay, next one is heavy metal removal. This was a project done by our friends BioVista in Bangladesh for Square, which is a pharmaceutical company. They need RO water. They used to have groundwater, which they treated first with sand filter, then with activated carbon, and then with the cartridge filter as a safety filter, and they had huge problems. They had huge problems with iron, and especially with pseudomonas. So you see, you know, iron level are really high, and also quite high turbidity. Also, it's groundwater and huge problems with pseudomonas. And we replaced this just with good aeration for 2 hours of the groundwater, followed by some coagulation, followed by AFM filtration at 5 meters. So they all really followed completely our recommendation, and look what they have achieved, you know, from 10 to 0.03. Would I promise you this blindly? No. Usually we promise a factor of 20, you know, this is a factor of nearly, I don't know, more than 100. So they have done it extremely well, but you can do this, and also with arsenic, but also on the turbidity was good, and especially we solved all the problem with the Pseudomonas. And now we are moving to South Korea. That's yours.
Yes. So the next one is cooling tower makeup water filtration from our partner Hoimyang in South Korea. Water source was surface water from a river, capacity 180 meter cubes per hour for 3 cooling towers. And you can see the feed water quality here with a turbidity of around 10 NTU. Achieved was less than 0.5. And also, if you look at the reduction of other parameters,
suspended solid,
solid, massive reduction. This was mainly using grade 0.
This was also before we had the NG, I mean, to mention it. And last but not least, one more, tertiary treatment. Let's move to South Africa. This is from our partner and friends from Aqua. Tertiary treatment of a sewage effluent for irrigation. Again, very nice Culpilus filter they installed. And you see again suspended solids from 93 to 4, E. coli gone, and also COD heavily reduced. So also thank you for this. We are out of time, so let's go to the next one. So to summarize, you know, you always see now sand and AFM. 1 means okay, and 4 means excellent. So removal of suspended solids, excellent with AFM. Bacteria, sand is bioactive, so you can even have more bacteria after, not with AFM. Iron and manganese removal. I mean, you can use this as pre-treatment and then use something else to remove it, but AFM alone can do a great job on this. And last but not least, one more, Philip. Why? Particle size.
Right.
20 with sand, 1 with AFM. And can you go to the next one? We will also talk later on about the return on investment. You know, we can do some return on investment calculation. We don't want to do this with each and every small project, but in the beginning, we are happy to assist this. I mean, what we can promise you blind, this was a little bit more than 1. What we can promise you more or less blind is 5 years. I mean, let's look in the data, but that's, I haven't seen, have you seen one project where we had more than 5 years? I haven't. Not in pools, not in water treatment. I haven't seen one. But I
mean, these are very case specific, yes. So that's why we need to talk together. We need to get your data.
Process, raw water, product water data, and then we can go through this. Okay, we are a little bit over time. Sorry for this. This is because of these 2 guys.
Yes.
In a week, we meet again, and then we talk about the pre-treatment of RO, and this is the agenda. And now it's time for Q.